Hi, so in this video I'm going to talk about trapezoid integral implementation. So let's get started. I'm going to include the IStream as usual, and I'm going to use the namespace std standard. I'm going to have two methods, prototypes, integrate. I'm going to specify the interval, so the start of the interval will be A, the end of the integrating interval will be B, and of course I'm going to have n steps, and I will have double f. It's going to represent the function I would like to integrate. In math we usually denote it with f, so I'm going to denote it too. So in the main function, I just want to see out the integrate. For example, I would like to integrate from 0 to 1. I will have 1,000 steps and end line. Of course, I have to implement the integrate method with double A, double B, integer n, and I will have a method double f, and the method I would like to integrate will be a simple method to be able to test our algorithm. So it will be the quadratic function x times x. It is the parabolic function. So if you are familiar with how to integrate a function, we can do it even in head. So for example, from 0 to 1, the integrate is x cubed divided by 3 from 0 to 1, so it will be 1/3. 0.333. That will be the solution. So how to calculate it with the help of trapezoidal rule? I will have a step size, and double h is equal to b minus a. It's going to be the size of the interval, and I have to divide it by the number of steps. So it's going to get me the step size. And I will have a double sum, and as we have discussed in the theoretical video, it's going to be 1 times O.5 times f A plus fb, and I will have a fourth cycle from int I equals to 0, 1 for example, I is less than n, I plus plus. I just have to iterate through with this step size, and we'll have a double x. These are the current x's, a plus h times I. So we iterate through I is the index. So when it's 1, it's just going to be the start of our interval plus h, the step size, then 2 times the step size. So we keep hopping from A to B. And of course, I have to calculate the sum plus f x. And of course, I have to return the sum times h. Okay, so let me run it and let me test whether it's working fine or not. And it's working fine. If you want to integrate the constant, for example, not the constant, for example, the linear, it's going to get us a half, because the integrate of x is equals to x squared divided by 2. From 0 to 1, it's going to be 0 plus 1 squared divided by 2. I think it's going to be a half. Oh, I should save it, I think. A half, yeah. And if I'm going to integrate a constant, for example 1, Let me see what will be the result. It's going to be 1. It is independent. If we integrate 1, it's going to be x, and x on the time at the 0 and at 1, so it's going to be 1. If it would be 2, for example, then it's going to be 2. Okay, so the integral is working fine. In the next video, we are going to talk about the Simpson formula, which is a bit better approximation of the integral. Thanks.